All right, so now we're going to actually solve the differential equation involved here now that we've talked sort of about its general character. Now we're going to solve this. In general, you will not have to do this procedure. You can just focus on the result that we get at the end. However, do sort of follow along. And if you want, by the way, try and do it on your own at various steps. You could just start now, or you could sit, once we start it and you sort of see where it's going, try to finish it. You know, you actually could solve this right now, solve this differential equation for a p as a function of t. All right, so that's what we're going to do together now, though. So we're going to start with, here's our equation. So I need to separate the variables. So the first thing is to I got to bring this p 1000, I got to bring all the p stuff over here, and I can only do it by dividing. That's the nature of separation of variables. And if I can't bring over the p over there just by dividing or multiplying, then I'm into a whole other class of functions that have a whole other theory to them, which you would learn in differential equations class in college. Now, what I've done is leave the 0.003 here. I could have brought the 0.003 over there, but I left it here mainly because I'm just copying the book. And by the way, you are invited to follow along page 366 of example 5. Just follow it along, or if you prefer, just study that, see if it makes sense to you. But my goal here is to write it all out and follow along and discuss it so it makes sense. All right, so now I need to do antiderivative on both sides, right? So my problem over here is what I need to antidifferentiate is a rational function. Oh, that's why we studied all these, right? So I need to do the integral of this, and in order to do that, I need to sort of take an aside here, and we're going to look at how do I do the integral of 1 over p times 1000 minus p dp. That's what I have to do. It's a rational expression. It's a rational integral. The denominator not only factors, it's already factored. So I'm going to start by using the method of integration by parts. So I'm going to have 1 over p times 1000 minus p equals, so we set it up as a over p plus b over 1000 minus p. I'm always forgetting to close that parenthesis. So then we multiply by p times 1000 minus p. We get 1 equals a times 1000 minus p plus bp. And then we distribute out the a, and we get 1 equals 1000a minus ap plus bp. Remember, p is a constant throughout all of this. Oh no, p is the variable. A and b are constants, yeah. All right. Anyway, so now we equate the constant part here, which is going to be 1 equals 1000a, and then the variable parts, I have 0p over here, if you want, let's put in 0p. So my second equation from that is 0 equals negative a plus b. All right, so from this I pretty directly get a equals 0.001, and from this I get a equals b, so since a equals 0.001, that means b equals 0.001. So I got the a and the b pretty easily there. So now I can say that, all of this is just to get this integral over here. All right, so now I can say that my integral of 1 over p times 1000 minus p dp is equal to the integral of 0.001 over p dp plus the integral of 0.001 over 1000 minus p dp, right? That's just putting the a and the b being 0.001 in both places, and I split the integral just to, because I felt like it. Now, the next thing the book does that is fairly clever, which I thought was a good idea. Wait, did they do that yet? Yeah, okay. All right, so we have this integral. They didn't do it yet, so I'm thinking ahead what they're going to do. So now we know what this integral is. So now we can bring ourselves back into this equation and say, I'm going to go ahead and do my antiderivative on both sides. So doing integrating with respect to dp on this side and integrating with respect to t on this side. All right, so I can write my new equation. So my new equation is going to be integral of, so this is sort of the trick, is we don't do the integral yet. Integral 0.01 over p dp plus integral 0.001 over 1000 minus p, because that's what we determined that integral is, equals, and what's the antiderivative of 0.03? Oh, I'm sorry, this was not 0.03t, it's 0.0303 dt, because there was no t over here. There was no t in this equation. So that means there's no t here. So where I got that t, though, is that now we're supposed to do the antiderivative of this. So now we're going to have 0.003t. And I'm not going to put the plus c yet because I still have integrals in the equation. All right, so that's what we got there. Now, this is the clever thing I thought that the book did. Actually, there's 3 zeros in this, aren't there? Jeez. There's 3 zeros in that. Nice, in our moose equation. Okay, 3 zeros there, 3 zeros there, 3 zeros there. Okay, now, so what they did was they multiplied, before doing the antiderivative, they multiplied both sides by 1,000. Because you can do, you know how you can factor out a constant? Well, you can also factor in a constant. So what they did was they just multiplied both sides of the equation by 1,000 just to get rid of the decimals, which is a good strategy. Simplifies the work a little bit. So we're going to multiply both sides by 1,000, and then we have integral of 1 over p. See how much nicer that is? dp plus the integral of 1 over 1,000 minus p dp, I need my dp up here, equals 0.0003t. All right, now I'm going to do these integrals. So integral of 1 over p, ln, absolute value of p. Now I do need the absolute value because I'm doing an antiderivative, so that's where we'll pick up the antiderivative. This one's going to be ln absolute value of 1,000 minus p, but then I have an inside function of -1. So I'm going to take, right, so I have to multiply times 1 over -1. What I'm going to do is put a negative out there. That's that chain rule. All right, and now I've done all my antiderivatives, so I'm going to put in the plus c now. All right, good. Now, the book does this weird thing, which at first I was like, well, do you really need to do that? And it pays off later, because what they're going to do is they're going to combine these using log rules, right? So we're going to have ln of p divided by 1,000 minus p. So in the last homework I said, you don't need to condense things, using the logs if you don't want to. In this case, it's going to be greatly advantageous to do that. But we don't want the 1,000 minus p in the denominator. We want it in the numerator because that will allow us to split up the fraction. So how can I move this 1,000 minus p into the numerator instead of the denominator? Well, what they did was they multiplied both sides of the equation by -1. So that's sort of in anticipation of making some later steps easier. So the result is that the negative ln 1,000 minus p becomes positive ln absolute value 1,000 minus p. And the negative 1 times ln of p becomes minus ln absolute value of p. And then over here, I'm still multiplying everything by -1, so negative 0.003t minus c. Now, a lot of times, I wouldn't bother to say minus c. I would say, look, this is a different c from this one. In fact, you wouldn't have to change it. You would get the same result. However, it just sort of makes some nice consistency happen. All right? Then we can actually drop the absolute values, and here's why. So first of all, the population is always positive. All right, so let's note a couple of things here. The population is positive. We cannot have negative moose walking around, although it would be very interesting if we did, but we can't. We also, 1,000 minus p also has to be positive because p cannot be more than 1,000. Remember, 1,000 is the maximum population, so I can't have more than 1,000 moose. Basically, what would happen if I started getting close to 1,000 moose is that they would start dying off, we would just never reach that 1,000. So the population is never more than 1,000. That's what that carrying capacity of 1,000 means. Therefore, both of these terms are positive, and I can drop the absolute values. So you always need to come up with some kind of justification. If you want to get rid of the absolute values, you have to come up with some reason why you can do that. All right. Now, from here, we can put together the ln's. So we're going to have ln of 1,000 minus p over p equals negative 0.0003t minus c. And then, of course, if we want to solve for p, we need to take e to both sides, or put the ln to the other side as an e. So then I'm going to have 1,000 minus p over p equals e to the power of negative 0.0003t minus c. All right, so I've run out of paper and time, so I'm going to continue this on the next page in the next video.